So here, let's look at a simple scenario where we use the Clapeyron equation to describe ice and water. So let's consider the following example or scenario. Here, we want to find out the change in the melting point of ice if we increase pressure from 1 atmospheres to 10 atmospheres. And we know the following information. The melting point of ice is about 273.2 Kelvin, which is 0 degrees Celsius, about. The heat of fusion is 6,020 joules per mole. The molecular weight is 18 grams per mole. The density of ice is 0.931 grams per cm cube, and the density of water is slightly larger at 1 gram per cm cube, and that is why ice floats in water. So the first thing we need to do is to figure out the molar volume of ice, and we do that by taking its molecular weight divided by its density. Substituting in the numbers, we get 19.33 times 10 to the power of negative 6 meter cube per mole. So we have to do the same for water. Using the same formula, we can get the molar volume of water by dividing the molecular weight of water by the density of water. And this gives us 18 times 10 to the power of negative 6 meter cube per mole. So here, we are going to be able to figure out what is the volume change when ice melts, which is delta V. So this is the molar volume of water minus the molar volume of ice. Now, assuming that dV and dH do not change with temperature, and that dt is a very small change with regard to t, and hence we do not need to integrate, we can then substitute the values into the Clausius-Clapeyron equation. Substituting the data, we will get a change in T in negative 0.056 Kelvin. What that really means is that as pressure increases from 1 atmosphere to 10 atmospheres, the melting point of ice decreases. So here we are going to be able to understand the phenomenon of skating, or rather ice skating. Okay, pardon my drawing. I don't know if many of you have actually been, or most of you have actually gone ice skating before. But as you skate across the ice, you exceed a larger amount of pressure, which temporarily melts the ice below the skate and allows you to move forward on some kind of temporary track. And if you notice, in some of the ice skating rinks that you've been to, there are multiple tracks within the ice itself. That is because we've had a lot of skates exert a lot of pressure according to a single track. And this allows a skate to propel itself forward.